Okay, we are going to now practice drawing Lewis structures and then being able to tell the molecular geometry of the shape once we have the correct Lewis structure. Okay, so our first example is going to be PH3. So what you do first is you get the correct Lewis structure. So P has 5 valence electrons. 3 hydrogens have 3, so we have 18 total. Okay, so we draw our Lewis structure. Okay, we subtract how many we just used. Oops, 8, not 18. 2, 4, 6. We have 2 left. We cannot put them on hydrogen, so we're going to put them on our phosphorus. Okay, now get out your green sheet. Focus on the central atom, phosphorus. You have to ask yourself, how many things is he bonded to, and how many lone pairs does he have? So if we take a look, phosphorus is bonded to 1, 2, 3 things. So there's 3 bonds. Okay, he also has 1 lone pair. All right, so we take a look at our green sheet, look at the middle column. We're looking for 3 bonding, 1 lone pair, and it's in that last section, trigonal pyramidal. So the molecular shape is trigonal pyramidal. And that's just how easy it is. You focus on the central atom, you ask yourself how many things does he bond to, how many lone pairs. All right, let's do another one. Okay, sorry about that. H2S. Okay, so we'll draw the Lewis structure. 2 hydrogens have 2 valence electrons, plus a sulfur has 6 valence electrons, so we have 8 total. Hydrogen never goes in the center, so we have sulfur with 2 hydrogens. We subtract 4. 4 left. We never put dots on hydrogen, so we put our 4 left as lone pairs on the central atom. All right, look at your green sheet. Now we need to look and focus on sulfur. How many things is sulfur bonded to? So it's got 2 bonding, 2 lone pairs. So we've got 2 things he's bonded to, 2 lone pairs. Look on your green sheet. The shape is bent. And if you notice, this is the bent shape with the star next to it. That means that this will be the bent on your test. Anything that has a star next to it on the green sheet will be on a test. Okay, and that's basically it. Let's do some more. Okay, C2S. Carbon has 4. 2 sulfurs would be 6 times 2 is 12, 16. Carbon's the central atom. Minus 4. We have 12 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Carbon's not happy, so we're going to double bond both sides. All right, and there's our Lewis structure. Focus on the central atom. How many things is he bonded to? Even though they're double bonds, he's still only bonded to 2 things. How many lone pairs does the carbon have? 0 lone pairs. So if you look at your green sheet, 2 bonding, no lone pairs would be linear. Okay, so it's just that simple. I think there's another one. Yep. C2H6. All right, so we have 2 carbons. 4 times 2 is 8. 6 hydrogens would be 6, so that's 14. All right, this one has 2 central atoms, 6 carbons, so they want to be symmetrical, so we go 3 and 3. Okay, we subtract how many we just used. 2, 4, 6, 8, 10, 12, 14. We are out of dots, we're out of electrons. Everybody's happy. Okay, so now here's the hard part. Anytime you have a molecule that has 2 central atoms, we need to find the shape of each one. So we need to find the shape around the carbon on the left. Then we need to find the shape around the carbon on the right. So let's start with the carbon on the left. He is bonded to 4 things, 4 bonds, has no lone pairs. So if you look at your green sheet, this carbon would be tetrahedral. Now you do the same thing for the other carbon. He's bonded to 4 things, has no lone pairs, so he would also be tetrahedral. You could write it like this. You could write it 2 tetrahedrals. You could write it tetrahedral times 2. But anytime you have 2 central atoms, multiple central atoms, you have to get the shape around each one. All right, and this concludes the part of 8.3 that we're going to get to. The rest of it will be done next week. All right, thanks.